In this second video on graphical analysis of objects' motion, we are going to cover the graphs of objects where the velocity is increasing or decreasing, that is when it is accelerating or decelerating. Previously, we have learned the displacement time graph and velocity time graph of objects at rest and objects traveling at constant speed or uniform velocity. We have learned that the gradient of the displacement time graph gives us the velocity of the object, and the area under the velocity time graph gives us the distance traveled. We have also learned that when an object's velocity is not constant but increasing, then it is said to be accelerating. If its velocity increases by the same amount at every time interval, example, say with each 1 second, its speed increases by 5 meters per second, then we say it is having uniform acceleration. If we plot its velocity on the velocity time graph, we will get a straight line for the velocity time graph. Its displacement time graph, however, will be an upward sloping curve. Just as we have learned previously, the area under the velocity time graph will give us the distance traveled, while the gradient of the tangent to any point on the displacement time graph will give us the velocity of the object at that particular point in time. Now, the gradient of the velocity time graph will give us the acceleration of the object. So when an object is increasing its speed at a constant rate, the acceleration is constant, and that's why the graph is a straight line. If the object is not accelerating, that is in the case of uniform velocity, then the acceleration is zero. So the line is horizontal and the gradient of a horizontal line is zero. Next, let's look at objects moving with increasing velocity, but the rate of increase is not constant. We say the acceleration is non-uniform. As in this case, the car's velocity increases from rest, that its velocity is zero, then to 11 meters per second, then next to 16 meters per second, and finally 17.5 meters per second. If you compute its acceleration, you will find that the acceleration is not constant. So when you plot the velocity on a velocity time graph, you will no longer get a straight line, but you will get a curve. Take note that this is a case where the velocity increases with decreasing rate, that is, decreasing acceleration. So you will get a convex curve for the velocity time graph. As for the displacement time graph, because the velocity is still increasing, the distance covered is still increasing, so the curve is concave. On the other hand, if the car is increasing its velocity but at an increasing rate as shown here, then you will get a concave curve for the velocity time graph. Whatever is the case, the area under the velocity time graph will always give us the distance traveled. The gradient of the tangent to the velocity time graph at any point will give us the acceleration at that point in time. The gradient of the displacement time graph will give us the instantaneous velocity of the object at that point in time. Remember all these points and you will be able to solve any GCE O-level kinematics questions involving graphical analysis. Visit my website and try out some questions to test your understanding. If you can solve them, you are ready for your exams. If you want a more detailed explanation for this topic on graphical analysis, get my full course. I've provided the respective links to my website and to the course in the description section below this video. If this video has helped you, do subscribe to my channel.